Hello friends, this video on Binomial Theorem Part 4 is brought to you by examfear.com. No more fear from exam. Before watching this video, you should have watched Part 1 to Part 3. So here we'll try to prove the same using combination logic. So what I'll do is, I'll try to say A1 plus B1 into A2 plus B2 into A3 plus B3. I'll first try to find the multiplication of this. So if I multiply these two, what I'll get is, let me first take product of this. So I'll get A1 plus B1 into A2 A3 plus, multiply this with this, plus A2 B3 A2 B3 plus B2 A3 B2 A3 plus B2 B3. Now let me multiply A1 B1 with this. So what I'll get is A1 A2 A3 plus A1 A2 B3 plus A1 2 A3 plus A1 B2 B3 plus, I'll say plus here, now we'll take B2 B1 actually, B1 A2 A3 plus B1 A2 B3 plus B1 B2 A3 plus B1 B2 B3. What I have done, I have multiplied A1 with this all, then B1 with all. So I got this. So if you see, there are 8 terms. This is almost equal to, so if I am asked to create 3 numbers A1 B1, so if you see, this has number from A1 A2 A3. So these are 3 buckets. This is bucket 1, bucket 2 and bucket 3. So this term has values from bucket 1, bucket 2 and bucket 3. This term also has values from bucket 1, bucket 2, bucket 3 because 1, 2, 3. This term also has values from bucket 1, 2 and 3. All these terms, if you see, has values from bucket 1 and bucket 2, bucket 3. No term is A1 into A1 into A1 or A1 into B1 into B1. All these terms has values from all these 3 buckets. So if you go by your combination logic, this is nothing but, in bucket 1 you have 2 items, that is A1 and B1. From there you are taking 1 item, 2C1. Similarly in bucket 2 you have 2 items, from there you are taking 1 item. From bucket 3 you have 2 items, that is A3 and B3. From there you are taking 1 item. So what you get, 2C1 into 2C1 into 2C1 is equal to 2 into 2 into 2 is equal to 8. So we see that all the 8 possible combination from 3 buckets 1, 2 and 3, where we have 2 values A1, B1, A2, B2 and A3, B3 is there. This is nothing but all the possible combination. So that means we can see a combination pattern here. We can apply some combination pattern. Correct. So let's assume now A1, now we'll assume A1 is equal to A2 is equal to A3 and B1 is equal to B2 is equal to B3, because we wanted to find A plus B whole cube. That was our intention. We wanted to find A plus B whole cube. Just to explain that there is a combination pattern involved, I have made A1 B1, A2 B2 and A1 A3 B3. So this guy becomes, if you solve this, this becomes A cube plus 3A square B plus 3AB square plus B cube. Now as I've already proved that there is a pattern here, the combination pattern here. So in the pattern you see, you either select A or B. If you select A, by default, because there are only 2 things to be selected, you select A, the remaining is B. If you select B, the remaining is A. So let's try to first derive the formula by selecting B. We select B. So in this case, when I say I'm to select B, so we have 3 B's, correct? So we say 3C0, because in this term we are not selecting any B. 3C0 is the number of possible combination of this 3C0 A cube. Now we'll say we want to select 1B. So it becomes 3C1 and this coefficient is A square B. Now we have to say we are selecting 2B, 3C2 into AB square. Because when you select 2B, obviously you can have only 1A. Because we are supposed to have this number of terms constant. That also we have seen in the pattern that the sum of the integers is always constant. And now we have to select 3B. So it becomes 3C3 into B cube. because if you have selected 3b, we can't select a because we are to select only 3 numbers. So what we have done, the number of ways we can select 0b is 3c0. So in that case we'll get a cube. The number of ways we can select 1b is 3c1. So there we'll get b into a square because the rest 2 term will be a. The number of ways we can select 2b is 3c2. If we have selected 2b, we can have only 1a. The number of ways we can select 3b is 3c3. So if you expand this guy becomes 3c0 is 1. This becomes ac3, a cube plus 3c1 is 3, 3a square b plus 3c2 is again 3, 3ab square plus 3c3 is 1, b cube. So thus we have seen this formula holds true. The same thing we are getting. This and this are same. Now again let's try with the selection of b because we can select a also instead of b. So now if we have to find the number of terms for a cube, so we have to say 3c3 into a cube because here we are trying to find the number of ways we can select 3 a's, that is 3c3. Now we are supposed to find for 2 a's. 2 a's, that means 1b. So it is 3c 2 a's. And now we will see for 1a, that will become 3c1. So obviously there will be 2b. And then we'll have 0 a's. 0 a's will be 3c0. This will become b cube. So if we solve this, 3c3 is equal to a cube 1 plus 3c2 is equal to 3 into a square b plus 3c2 3c1 is equal to again 3ab square, and this also becomes b cube. So if you see here also we get the same formula. Correct. So the pattern we are following here is we are trying to find NCR from the number from a plus b to the power n. We'll find NCR where r is equal to 0 to n. So here we'll say r is equal to 0 first, we'll say then r is equal to 1, keep on doing for n. And then we'll say a to the power r. The moment we say a to the power r, b obviously becomes n minus r. Correct? Because we have selected a, the b is by default the part. And we have to find this thing from r is equal to 0 to n, we'll say summation r is equal to 0 to n. So this is nothing but the formula of a plus b to the power n. This we have derived using combination logic. So what we have done, we have to find a plus b to the power cube. To do this, we have first created a1 plus b1, a2 plus b2, a3 plus b3. Just to explain that the combination logic involved, we have multiplied, we got 8 values, and we saw that each of these values has numbers or items from bucket 1, 2 and 3. And we also proved that combination logic that there should be 8 items, and we actually found that there are 8 items. That means it confirms that combination logic is present here. Then we have said a1 is equal to a2 is equal to a3 and b1 is equal to b2 is equal to b3. So we have got this formula. To prove this formula, we have taken two approaches. Either we select a or we select b. Because if we select a, then b is by default selected, and if we select b, a is by default selected. So if we select a, b, then we are saying 0b selected, that is 3c0, 1b selected, 3c1, 2b selected, 3c2, 3b selected, 3c2, 3c3, and we got this formula. When you say we select a, then when I say a cube, that means I am selecting 3a, so it becomes 3c3. When I say a square, I say 3c2 because I am selecting 2a. When I say a to the power 1, I say 3c1 because I am selecting only 1a. When I am saying a to the power 0, I say 3c0. So we have seen the pattern, and the pattern was you are doing nothing but you are trying to select a or b. Let's suppose in this case we are selecting a. A we are selecting from 0 to n, so we are saying 0 to n. So we are saying NCR, a to the power r, b minus r, b to the power n minus r, because when I say r is equal to 0, I am saying NC0. When I am saying r is equal to 1, I am saying NC1. When I am saying r is equal to 10, I am saying NC10. So that's why we have got this formula from combination logic. So thus what we have seen that we have proved this combination formula using three pattern. One using induction, the other using the pattern, and third using the combination logic. Let's review the binomial theorem formula once again. A plus b to the power n is equal to nc0 a to the power n. Increase the value of the nc0 to nc1, this becomes nc2. You keep increasing, ncn minus 1. Similarly b, A you keep decreasing the value of an minus 1, an minus 2, an minus 3, and minus 4, to the an minus a is equal to 1, and a is gone. Similarly for b, this is b to the power 0, this become b to the power 1, this become b square. You keep increasing this becomes b to the power n minus 1, and this becomes b to the power n. So this is the formula. Also we can write this formula as summation of nck a to the power n minus k b to the power k, where k is equal to 0 to n. We have proved this using combination logic, also using induction and using pattern. Also we have observed that total number of terms in the expansion is n plus 1. So when you are saying a plus b to the power n, so this will have n plus 1 term. For a plus b to the power 2 is equal to 3 terms, because 2 plus 1 is equal to 3. Also the first quantity a goes decreasing, whereas the power of second quantity increases. We have seen a to the power n, a to the power n minus 1 goes decreasing, b to the power 0, b to the power 1, b to the power 2, it goes increasing. Also some of the coefficient of the a and b in any term is same. So if you see n plus 0 is n, n minus 1 plus 1 is n, n minus 2 plus 2 is n, everywhere it's n. Here also in the common formula also you can see n minus k is equal to n minus k plus k is equal to. Thank you. Visit examfear.com to watch free educational videos, try free online test, get the best quality study material, study from the best tutor and mentors, and much more. Thanks once again.